welcome to the deep dive. Today, we're diving into something that trips up a lot of folks in networking.
Yeah, especially if you're looking at that CompTIA Network plus N10-009 certification.
Exactly. We're talking at acronyms. That huge list seems endless, right?
It really can feel overwhelming, like learning a whole new language.
Our mission today, make sense of it all. We're here on Acronym Academy to, well, demystify these acronyms, make them stick, maybe even fun.
That's the goal.
Yeah.
Seriously though, understanding these is fundamental, not just for the exam, but for actually doing networking.
Totally. So we're not just going to read a list, we'll group them, find connections, use some analogies, make it easier to remember.
And we are planning to hit every acronym from that official N10-009 list. So if you've got the PDF handy, follow along. If not, no worries, we'll cover it all.
Maybe grab a pen, jot things down, active listening, it helps.
Definitely. Okay, ready to jump in?
Let's do it. First up, the absolute basics. How devices get names and find each other. Category 1, addressing and naming.
Right, the bedrock. You can't send a letter without an address. Same idea here. And the most fundamental address is IP.
Internet Protocol.
Yep. That's the core rule book for routing data packets across networks. The internet basically runs on IP. It's how your computer finds, say, the Acronym Academy server.
And then there's the hardware address, right? The MSC address.
Exactly. Media access control. Think of it like the serial number burned onto the network card itself. It's unique to the physical hardware.
So IP is logical, MACE is physical. Got it.
Precisely. But we don't browse the web using IP addresses, do we? We use names like acronym.academy.
Right. Much easier to remember.
That's where DNS comes in. Domain name system. It's like the internet's giant phone book. It translates those easy names into the numerical IP addresses computers need.
Ah, okay. The translator. Makes sense.
And how do devices usually get their IP addresses in the first place? Often, it's automatic thanks to DHCP.
Dynamic Host Configuration Protocol.
Right. Imagine you walk into an office network, plug in, and boom, DHCP gives your laptop an IP address, tells it where the gateway is, the DNS server.
Yeah.
Everything it needs to get online, automatically.
Super convenient. But what if the DHCP server isn't working?
Good question. That's where APP kicks in. Automatic Private Internet Protocol Addressing.
Okay.
It's a fallback. If a device can't reach a DHCP server, it can assign itself a special IP address in a specific range, like 169.254 dot something.
So it can still talk to other devices on the same little network segment.
Exactly. Limited local communication. But it can't get out of the internet usually. It's assigned something's wrong with DHCP.
Okay. Now, most home or office networks use private IP addresses, right? Like 192.168 something. But we share one public IP from our ISP. How does that work?
That's NAT, Network Address Translation.
Like a receptionist for the whole network?
Kind of. It takes all the outgoing traffic from devices with private IPs and makes it look like it's coming from that single public IP address. And it keeps track so replies get back to the right device. And often, it's actually PATI, Port Address Translation, doing the heavy lifting. It's a type of NAT.
How is PAT different?
PATI uses port numbers along with the IP address. So multiple internal devices can use the same public IP at the same time for different connections, because PAT assigns unique port numbers to track each conversation.
Got it. More granular tracking.
Yep. Now, FQDN isn't officially on the list, but it's related. Fully qualified domain name.
What's that?
It's the full, unambiguous name within DNS, like www.acronym.academy.
Yeah.
With the dot at the end sometimes, the whole hierarchy.
Okay, the complete address, and finally, URL.
Uniform Resource Locator. That's what you type in your browser bar. https://acronym.academy videos or whatever. It includes the protocol, the domain name, which DNS resolves, and the path to the specific resource.
Okay, so that wraps up addressing and naming. It's all about identity and location online.
Pretty much the foundation for everything else. Now let's talk about protecting all this. Next category, security.
Oh yeah, this is a big one. Lots of acronyms here. Where do we start?
Let's start with controlling access. ACL, Access Control List.
Like a bouncer's list at a club door.
Exactly. It's a set of rules on a router or firewall saying what traffic is allowed or denied based on things like IP address, port number, protocol.
Filters the traffic. Okay.
Now, for securing the data itself as it travels, especially between networks, we have IPsec, Internet Protocol Security.
That sounds important.
It is. It's a whole suite of protocols. Two key parts are AH and ESP.
AH and ESP.
Authentication header, AH, verifies the sender is who they say they are and that the data hasn't been messed with. integrity, and authentication.
Okay, and ESP.
Encapsulating security payload.
Yeah.
This one provides confidentiality, it encrypts the data, it can also do integrity and authentication like AH, often used together in IPsec.
So IPsec makes the communication secure and trustworthy.
Right, and it's often the technology behind VPNs.
Virtual private networks, like a secure tunnel through the internet.
Perfect analogy. It encrypts your traffic between your device and a private network, making it seem like you're directly connected, even over a public network like the internet. Essential for remote access.
Makes sense. What about watching out for bad guys on the network?
Good point. We have IDS and IPS.
Intrusion detection and intrusion prevention.
You got it. An IDS, the detection system, is like a silent alarm. It watches network traffic, spots suspicious patterns, and alerts an administrator. But it doesn't step in.
Just detects, so IPS.
The prevention system does step in. It not only detects malicious activity, but actively tries to block it or shut it down. It's more proactive.
Got it. Detect versus prevent. Now, what about those attacks that try to overwhelm websites?
Ah, yes. DNS and DDoS, denial of service.
That's the difference.
A DOS attack comes from a single source trying to flood a service with traffic. A DDoS, distributed denial of service, is much nastier. It uses a whole army of compromised computers, sometimes thousands, all attacking at once. Much harder to stop.
Yikes, okay. Underneath all this security stuff, there are some core ideas, right?
Absolutely. The CIA triad.
Not that CIA.
No. Confidentiality, integrity, and availability.
Okay, break this down.
Confidentiality. Keeping secrets secret. Preventing unauthorized disclosure. Integrity. Making sure data is accurate and hasn't been tampered with. Availability. Ensuring authorized users can access the systems and data when they need to.
Those three guide basically all security decisions.
Pretty much. And related, though not on the main list, is AAA.
AAA.
Authentication, authorization, and accounting. Who are you? Authentication. What are you allowed to do? Authorization. What did you do? Accounting. Foundational for access control.
Which leads nicely into IAM.
Identity and access management. Yes. This is the whole framework, the policies, the technologies for managing who users are and what they can access across the organization.
And a big part of proving identity now is MFA, right?
Multi-factor authentication. Huge. Requiring more than just a password. Like a password plus a code from your phone app or a fingerprint makes it much harder for attackers.
Definitely. What about controlling which devices can even connect to the network?
That's NAC. Network Access Control.
How does that work?
NAC systems check devices before they're allowed full network access. Does it have antivirus? Is the OS patched? Is the user authorized? It enforces health and security policies at the entry point, like a security checkpoint.
Makes sense. And for trust online, things like certificates.
That's PKI. Public key infrastructure. The whole system of creating, managing, distributing, and revoking digital certificates. These certificates verify identities and enable encryption. It's the backbone of secure web browsing, for example.
Speaking of secure web browsing, SS and TLS.
Right, Secure Sockets Layer, SSL is the older one, largely replaced now by TLS, Transport Layer Security. They both provide encryption for communication over a network. You often see SSL TLS.
And that little padlock icon in the browser, that usually means HTTPS.
Exactly, Hypertext Transfer Protocol Secure. It's just regular HTTP web traffic, but encrypted using SSL TLS. Essential for logins, shopping, anything sensitive online.
Okay. What about secure command line access, like logging into a router?
That's SSH, Secure Shell. It encrypts the entire session, so passwords and commands aren't sent in the clear. Much better than older protocols like Telnet.
And secure file transfer?
We've got SFTP, Secure File Transfer Protocol. It usually runs over SSH, so it's encrypted. There's also FTPS, not on the list but related, which adds SSL TLS to the old FTP protocol. SFTP is generally preferred now.
What about securing DNS itself? We mentioned DNS earlier.
Good point. DNS SEC, Domain Name System Security Extensions. It uses digital signatures to verify DNS responses, preventing attackers from spoofing DNS records and sending you to malicious sites. Adds trust to the phone book.
And encrypting the actual DNS lookups.
Yes. Two big ones there. DOH, DNS over HTTPS, and DDoT, DNS over TLS. They both encrypt a query from your computer to the DNS server, preventing eavesdropping on what websites you're visiting. Big privacy boost.
Moving to wireless, WPA.
Wi-Fi protected access. That's the security protocol family used to secure Wi-Fi networks. WPA2 and now WPA3 are the common standards you should be using.
And what about WPS, that button on the router?
Wi-Fi protected setup. Yeah. Be careful with that one. It was designed for easy setup, but it has known security flaws that make it easy for attackers to crack your Wi-Fi password. Generally, best to disable it.
Good tip. Okay, last one in security for now. ZTA.
Zero trust architecture, a really important modern concept. The core idea is never trust, always verify.
Meaning?
Don't automatically trust any user or device, even if they're already inside your network. Continuously verify identity and permissions for every access request. Assume threats can come from anywhere.
A much stricter security posture. Okay, that's a lot on security.
It's crucial stuff. Now let's shift gears to the physical gear and network structure. Category 3, networking devices and infrastructure.
Right, the hardware, starting with the absolute basic, NIC.
Network interface card. The piece of hardware, either wired or wireless, that lets your computer actually connect to the network medium, your Ethernet port or your Wi-Fi adapter.
And for Wi-Fi, we connect to an AP, right?
Access point, correct. The device that broadcasts the Wi-Fi signal and connects wireless devices back to the wired network, often built into home routers.
Okay, what's BSSE?
Basic Service Set Identifier. In simple terms, it's usually the MAC address of the wireless access point, the unique hardware ID of that AP.
And ESID, that sounds similar.
Extended Service Set Identifier, that's the name of the Wi-Fi network that you actually see and connect to, like Acronym Academy Wi-Fi, your SIG.
Ah, okay. BSID is the MASI, ESE is the name, got it. No, VLAN.
Virtual Local Area Network.
Yeah.
Super useful. It lets you logically divide a single physical switch into multiple separate broadcast domains.
So you can group devices together, like the marketing team on one VLAN, engineering on another, even if they're plugged into the same switch.
Exactly. Great for security and organization. Keeps traffic separate.
And SVI.
Switch Virtual Interface. This is a logical Layer 3 interface on a switch that represents a VLAN. It allows the switch to route traffic between different VLANs, if you configure it that way.
Okay, how do we prevent loops if we connect switches together redundantly?
That's STP, Spanning Tree Protocol.
What does it do?
It intelligently detects redundant paths in an Ethernet network and blocks one of them to prevent traffic from looping endlessly, which would crash the network. Creates a loop-free path.
Is it fast?
STP itself is a bit slow to react to changes. That's why we have RSTP.
Rapid Spanning Tree Protocol.
Yeah.
Faster, I assume.
Much faster. It converges, meaning it recalculates the loop-free paths much more quickly after a network change, minimizing downtime.
Good. What about redundancy for the gateway? The router everyone uses to get out.
That's where FHRP comes in, First Hop Redundancy Protocol.
Like HSRP or VRRP.
Exactly. Those are examples of FHRPs. They allow multiple routers to share a virtual IP address, so if the main router fails, another one instantly takes over as the gateway. Keeps traffic flowing.
Essential for uptime. Okay, moving to the wiring closet. MDF and IDF.
Main distribution frame, MDF, and intermediate distribution frame, IDF. Think of the structured cabling in a building. The MDF is usually the central hub where external lines come in and major backbone connections happen.
And IDF.
Are smaller wiring closets, maybe on different floors or wings, that connect back to the MDF. They serve the local area connections. It's hierarchical.
Got it. What about powering devices over the network cable?
That's PoE, Power over Ethernet.
Super handy for things like
Wireless access points, IP cameras, VoIP phones, devices that might be installed where getting a separate power outlet is difficult. PoE sends power right over the Ethernet cable.
cool. And in server racks, those power strips?
PGUs, power distribution units. They take the main power feed and distribute it to multiple outlets for servers, switches, etc., often with monitoring capabilities.
Okay, that covers the basic infrastructure components. Let's talk about how data actually moves, routing and switching.
Right, switching is mostly about layer 2, using MAC addresses within a local network. Routing is layer 3, moving data between networks using IP addresses.
And how do they find the MAC address for a local IP?
It's ARP, Address Resolution Protocol. A device basically shouts out on the local network who has IP address 192.168.1.0, and the device with that IP replies with its MIC address. Then they can talk directly.
Okay, local address mapping. Now for routing between networks. Older protocols first.
Like RIP. Routing Information Protocol. It's a distance vector protocol.
Eating.
It basically just counts the number of routers,
Yeah.
hops, to reach a destination. The path with the fewest hops wins. Simple, but not always the smartest about bandwidth or actual speed.
So what's better?
Link-to protocols like OSPF, Open Shortest Path First.
How's that work?
OSPF routers build a complete map, like a topology database of the entire network area. Then they run an algorithm, Dijkstra's usually, to calculate the actual best path based on factors like link speed, cost. Much more sophisticated.
Okay. What about routing between huge networks like ISPs on the internet?
That's the domain of BGP, Border Gateway Protocol. It's the protocol that makes the global internet routing work. exchanging reachability information between different autonomous systems, like different companies or ISPs. Very complex, very critical.
Any other major routing protocols?
Well, Cisco has its proprietary one, EIGRP, Enhanced Interior Gateway Routing Protocol. It's kind of a hybrid, combines some distance vector ideas with faster convergence like link state, used a lot in Cisco environments.
NIS.
Intermediate system to intermediate system. Another link state protocol like OSPF. Very scalable, often used in large service provider networks. Less common in typical enterprise networks compared to OSPF, perhaps.
Okay. Now, what about these newer ways of managing networks? SDN?
Software-defined networking. Big shift. It separates the control plane, the brains making routing decisions, from the data plane, the hardware actually forwarding packets.
Why do that?
It allows for centralized control and automation. You manage the network via software, often a central controller, making it more agile and programmable. Less configuring individual boxes.
And SD-WAN builds on that.
Exactly. Software-defined wide area network applies SDN principles to the WAN connections between sites. Aims to simplify management, improve performance, for example, using internet links alongside private lines, and reduce costs for branch connectivity.
What's VXLAN? Sounds virtual.
Virtual Extensible LAN. It's an overlay technology. It lets you stretch Layer 2 networks, like VLANs, over a Layer 3 infrastructure. Think of creating virtual networks on top of the physical network.
Useful in data centers and clouds.
Hugely. It overcomes limitations of traditional VLANs, allowing for many more network segments and greater flexibility in virtualized environments. It encapsulates Ethernet frames in UDP packets.
And one more related idea, though not on the list, VRF.
Virtual routing and forwarding. Good one to know. It allows the single physical router to host multiple independent routing tables, like having several virtual routers inside one box. Great for securely separating traffic for different customers or departments at Layer 3.
Okay, that covers how data gets routed and switched. Let's get physical again, cabling and connectors.
The wires and plugs. Most common Ethernet cable. UTP.
Unshielded twisted pair. The standard blue, gray, yellow cables you see everywhere.
Yep. 4 pairs of twisted copper wires. Cost-effective, works well for most office environments.
But sometimes you need shielding.
Right. In electrically noisy environments like factories, you might use STP, shielded twisted pair. It has foil or braid shielding around the pairs to reduce interference. EMI.
Okay, what about fiber optics? FC?
Fiber channel? That's typically used for high-speed connections in SAN storage area networks, connecting servers to shared storage arrays.
Yeah.
Uses fiber optic cables.
And DSC?
Direct attached copper. These are special copper cables with transceivers built right onto the ends, used for short, high-speed links in data centers like connecting switches together or switches to servers, cheaper than using separate fiber transceivers for short runs.
The standard Ethernet plug is RJ45, right?
Registered jack 45, absolutely. The connector on the end of UTP-STP cables?
Now for fiber connectors, lots of those. LC.
Lucent connector, or local connector, very common now. Small form factor, push tab release, you'll see these a lot on modern switches and SFPs.
Is that Z?
Subscriber connector, also common, a bit larger than LC. Square shape, push-pull mechanism, easy to use.
And ST.
Straight tip, and older style. Round metal connector with a bayonet twist lock mechanism. Less common on new gear, but still around.
What if you need to connect many fibers at once?
MPO, multi-fiber push-on. A rectangular connector that can house 12, 24, or even more fibers. Used for high-density backbone connections, especially in data centers.
What about BNC? That sounds older.
Bayonet Neil consummate. Yeah, typically used with coaxial cable. You might see it on older Ethernet, like 10BASE-2, thin,
Wow.
or for video systems. Twist lock.
Okay, now the modules that use these connectors, the transceivers. QSFP.
Quad small. Form factor pluggable. Quad, because it often handles 4 lanes of traffic.
Yeah.
Used for high speeds like 40 Gbps, 100 Gbps, and even higher now. Compact, hot pluggable.
And just SFP.
Small form factor pluggable. The workhorse transceiver for 1 Gbps and 10 Gbps. Also compact, hot pluggable. You buy the SFP module based on whether you need copper, short-range fiber, multi-mode, or long-range fiber, single mode.
Was there something before SFP?
Yeah, the GBIC. Gigabit interface converter, larger form factor, did the same job as SFP, but took up more space. Mostly legacy now.
Okay, that's the physical layer sorted. Cables and connectors. Now, the services and protocols applications use. Network services and protocols.
The applications tools. Basic file transfer, FTP.
File transfer protocol. Old school, but still used. Sends username, password, and clear text, though, usually.
Yep, which is why we have secure versions like SFTP and FTPS we mentioned. There's also TFTP.
Trivial file transfer protocol. Simpler.
Much simpler. No authentication, uses UDP. often used for booting devices or transferring configs where security isn't the main concern.
Email. Sending email uses SMTP, right?
Simple mail transfer protocol, yes. That's the standard for server-to-server email transfer and when your email client sends mail out.
And getting email in.
Two main ones, POP3, Post Office Protocol, version 3, and IMP, Internet Message Access Protocol.
Different.
POP3 typically downloads email to your device and deletes it from the server. IMP synchronizes with the server so you see the same emails on multiple devices and they stay on the server. IM is more common now.
Managing network devices.
SNMP, Simple Network Management Protocol, used by management stations to query devices for status, performance stats, and sometimes configure them. Uses MIBs, which we'll get to.
What about collecting log messages?
Syslog, a standard protocol for devices and applications to send log messages to a central syslog server for storage and analysis. Invaluable for troubleshooting.
Keeping time synchronized.
NTP, Network Time Protocol, crucial for logs, security certificates, authentication. NGP clients sync their clocks with NTP servers.
Is there something more precise?
Yes, PTP, Precision Time Protocol, used in environments needing much higher accuracy, like industrial controls or financial trading. Nanosecond precision sometimes.
Voice and video calls over the network.
Often uses SOP, Session Initiation Protocol, for setting up, managing, and tearing down the calls. It's the signaling part.
And the overall technology is VoIP.
Voice over IP, yep. Transmitting voice calls as data packets over an IP network.
Remotely accessing another computer's desktop.
RDP, Remote Desktop Protocol, Microsoft's protocol, widely used for accessing Windows machines graphically.
Accessing directories of users and computers.
LDAP, Lightweight Directory Access Protocol, used to query and modify information in directory services like Active Directory.
Is there a secure version?
Yes, LDAP, LDAP over SSLTLS, encrypts the LDAP traffic. Very important.
File sharing in Windows networks.
Primarily SMB server message block,
Whoa.
also called CIFS sometimes, used for accessing shared folders, printers.
And in Linux Unix world.
Often NFS network file system, another common protocol for distributed file sharing.
Okay, those are the key services. How do we manage all this? Network management and operations.
Right, keeping the network running, interacting with devices, you might use the CLI.
Command line interface, typing commands, the classic way.
Yep, or you might use a GUI.
Graphical user interface, point and click. Easier for some tasks.
Depends on the task and preference. Now, with SNMP, the management station needs to know what it can manage on a device. That information is in the MIB.
Management information base, like a database of manageable settings.
Exactly. A structured hierarchy of all the objects, settings, stats that can be queried or set via SNMP on that device type.
What's MTU?
Maximum transmission unit. The largest size, in bytes, that a single data packet can be on a specific network segment before it needs to be broken into smaller fragments. Important for performance.
Measuring reliability, MTVF.
Mean time between failure. An average measure of how long a device or component is expected to run before it fails. Higher is better.
And when it does fail, MTTR.
Mean time to repair or restore. The average time it takes to fix the failed component and get it back online. Lower is better.
Contracts about service levels.
SLAs. Service level agreements. Define expected uptime, performance, support response times, etc., usually between a service provider and a customer.
Yeah.
Penalties if they're not met.
What about product life cycles, EOL and EOS?
End of life, EOL, means the vendor stops selling the product. End of support, EOS, means they stop providing patches, updates, or tech support. Crucial to know for security and planning upgrades.
Planning for the worst.
Disaster recovery. The plan and processes for recovering IT systems and network services after a major disruption, fire, flood, cyber attack.
And within DR, RPO, and RTO.
Recovery point objective, RPO. How much data loss is acceptable? Measured in time, e.g. we can afford to lose up to 1 hour of data. Recovery time objective, RTO. How quickly must the service be restored, e.g. the system must be back online within 4 hours.
Key metrics for business continuity. What about user rules?
AUP, acceptable use policy, defines what users are allowed and not allowed to do on the company network and systems.
And letting users use their own gear?
BYO, bring your own device. Policies and technologies around managing personal devices, accessing corporate resources, security challenges there.
Shifting to industrial settings, OT.
Operational technology, the hardware and software used to monitor and control physical processes, like in manufacturing, power grids, utilities. Different world from traditional IT sometimes.
Buying ICS.
Industrial control system, a category within OT. Systems like PLCs, programmable logic controllers that directly manage machinery.
And IoT.
Industrial Internet of Things, applying IoT concepts, sensors, connectivity, data analytics to industrial equipment and processes.
What about large-scale control systems? SCADA.
Supervisory control and data acquisition, often used to monitor and control processes over large geographical areas like pipelines or electrical grids, collects data acquisition, and allows operators to manage supervisory control.
Okay, managing the network day-to-day. Let's touch briefly on cloud and virtualization.
Big topics, but key acronyms. IaaS.
Infrastructure as a service, like renting virtual server storage networks from a cloud provider.
Exactly. You manage the OS and applications. They manage the underlying hardware. Think AWS EC2 or Azure VMs.
Platform as a service.
The provider manages the infrastructure and the OS middleware. You just deploy and manage your application code. Think Heroku or Google App Engine.
And SaaS.
Software as a service. You just use the software over the internet. Provider manages everything. Think Gmail, Salesforce, Office 365.
What's a VPC?
Virtual private cloud. Your own isolated slice of a public cloud provider's network. You define your IP ranges, subnets, routing, security, like your own virtual data center.
And NFE?
Network functions. Virtualization. Taking network functions that used to require dedicated hardware boxes, firewall, load balancers, routers, and running them as software on standard servers. More flexible, potentially cheaper.
Cloud and virtualization are definitely reshaping networking. Okay, last category. Miscellaneous. A bit of a catch-all.
Yeah, important bits that didn't fit neatly elsewhere. API.
Application programming interface. How different software programs talk to each other. Sets of rules and protocols. Crucial for automation and integration.
CDN.
Content delivery network. Those networks of servers spread around the world that cache website content closer to users, makes websites load faster.
Exactly. CPU.
Central processing unit. The main brain of a computer or network device does the processing.
CRC.
Cyclic redundancy check. An error detecting code. Used in Ethernet frames and other places to check if data got corrupted during transmission.
DASI.
Direct attached storage. Storage connected directly to one computer, not over the network, like an internal hard drive or a USB drive.
DCI.
Data center interconnect. High-speed links specifically designed to connect different data centers together.
EOCOL.
Extensible authentication protocol over LAN. Used in network authentication, especially with 802.1x port-based access control on wired and wireless networks, the mechanism for carrying EAP messages.
EOIA.
And user license agreement, that text you scroll past and click agree on when installing software. The legal terms. General Data Protection Regulation, the EU's strict data privacy law. Big implications for how companies handle personal data of EU residents.
GRE.
Generic routing encapsulation, a tunneling protocol, can wrap various kinds of packets inside an IP tunnel, used for some VPNs or connecting disparate networks.
HTTP.
Hypertext Transfer Protocol, the fundamental protocol for the World Wide Web. Used to request and deliver web pages. We saw HTTPS earlier, the secure version. Infrastructure as code. Managing and provisioning infrastructure, servers, networks, etc., using configuration files and code instead of manual setup. Think tools like Terraform or Ansible. Automation.
IoT.
Internet of Things, the vast network of everyday physical objects embedded with sensors and connectivity, allowing them to collect and exchange data, smart homes, wearables, etc.
IPM.
IP address management, systems and processes for planning, tracking, and managing the IP address space within an organization. Prevents conflicts, keeps things organized. Internet Key Exchange, part of the IPsec suite, used to negotiate the security parameters and generate the encryption keys for an IPsec tunnel.
LLDP.
Link Layer Discovery Protocol, a vendor-neutral protocol used by network devices to advertise their identity and capabilities to their direct neighbors on the network. Helps map the network. Cisco has its own version, CDP.
MX.
Mail Exchanger Record, a type of DNS record that tells sending mail servers where to deliver email for a specific domain. Points to the receiving mail servers. Name server record, another DNS record. Identifies the authoritative DNS servers that hold the actual DNS records for a domain. Operating system. The core software that manages the hardware and allows other applications to run. Windows, Linux, macOS, Cisco iOS.
PCI DSS.
Payment Card Industry Data Security Standard, a set of mandatory security requirements for any organization that handles credit card data. Very important for retail and e-commerce.
DTR.
Pointer record, DNS record used for reverse lookups, maps an IP address back to a hostname, the opposite of a standard or AAA record. Quality of service. Mechanisms for prioritizing certain types of network traffic over others. Ensures important stuff like VoIP calls or video conferencing get smooth performance even if the network is busy.
Wireless.
Remote authentication dial-in user service. A common protocol for centralized authentication, authorization, and accounting for network access. Often used for VPNs, Wi-Fi authentication with EAP, switch logins,
RFID.
radio frequency identifier. Uses radio waves to read information stored on tags attached to objects. Used in inventory tracking, access badges, contactless payments. Simply means receiver or receive. You'll see it on interfaces or in specs. Security assertion markup language. An XML-based standard for exchanging authentication and authorization data between parties, particularly between an identity provider and a service provider. Key for single sign-on. Storage area network. A dedicated high-speed network, often using fiber channel, that connects servers to shared block-level storage devices. Different from NAS, network-attached storage, which provides file-level access. Secure Access Service Edge, pronounced SASE. A newer cloud architecture concept. Combines network capabilities like SD-WAN and security functions like firewall, secure web gateway into a single cloud-delivered service. Security information and event management. Systems that collect log data from across the network, correlate events, analyze them for security threats, and provide alerts and reporting, like a central security dashboard.
SOA.
Start of authority record. A DNS record containing administrative info about the zone, like the primary name server, admin contacts, serial number, refresh timers. Every DNS zone must have one.
SQL.
Structured query language. The standard language for interacting with relational databases, querying data, inserting, updating, deleting. Security Service Edge. A subset of SaaS focusing specifically on the cloud-delivered security components, things like Secure Web Gateway, Cloud Access Security Broker, CASB, Zero Trust Network Access, ZTNA.
SSI.
Service Set Identifier. We mentioned this with ESET. It's the name of the Wi-Fi network.
TechCast Associates plus app.
Terminal Access Controller, Access Control System Plus. A Cisco proprietary EEE protocol, similar to Radius, but separates the authentication, authorization, and accounting functions more distinctly and encrypts the entire packet. Often preferred in Cisco environments for device administration.
TCP.
Transmission Control Protocol, one of the main transport layer protocols, provides reliable, connection-oriented, error-checked data delivery, used by HTTP, FTP, SMTP, time to live, a value in an IP packet header that gets decremented by each router. If it hits 0, the packet is discarded. Prevents packets from looping forever on the internet. Also used in DNS records to indicate caching time.
TX.
Transmitter, or transmit, the counterpart to RX,
TXP.
text record, a type of DNS record that can hold arbitrary text. Used for various purposes like domain ownership verification, for example, for Google Workspace or Microsoft 365, or for security policies like SPF and DKIM. User Datagram Protocol, the other main transport protocol. Connectionless, unreliable, best effort. Faster than TCP because there's less overhead. Used by DNS, DHCP, TFTP, some streaming media, online gaming.
EPS.
Uninterruptible power supply. A battery backup device. Provides temporary power during an outage, allowing systems to shut down gracefully or run for a short period. Essential for critical infrastructure.
USB.
Universal Serial Bus. The standard interface for connecting peripherals, keyboards, mice, drives, printers to computers.
UTM.
Unified Threat Management. An all-in-one security appliance, typically aimed at smaller businesses. Combines firewall, VPN, intrusion prevention, antivirus scanning, web filtering, etc. into a single box.
VIP?
Virtual IP address. An IP address that isn't tied to a single physical network interface. Often shared by multiple devices for load balancing. Requests go to the VIP and are distributed, or high availability, like with FHRPs.
And last but not least, VLSM.
Variable length subnet masking. A technique that lets you use different subnet mask lengths for different subnets within the same larger network block. Allows for much more efficient use of IP address space compared to using the same mask everywhere.
Woo. And that's the list. We made it through.
Yeah, we did. That's a comprehensive tour of the CompTIA network, plus N10-009 acronym landscape. A lot to take in, but hopefully breaking it down by category helped.
Absolutely. Getting comfortable with these acronyms really is a huge step, not just for the cert, but for understanding networking conversations, documentation, everything.
Definitely encourage you, the listener, to maybe go back through these categories, see which ones clicked, which ones still feel a bit fuzzy. Repetition helps lock it in.
Yeah. Which ones were surprising, or which connections between them suddenly made sense? Thinking about that reinforces the learning.
So here's something to think about. Now that you've got a better handle on this alphabet soup, how does understanding these building blocks change how you might approach troubleshooting a network problem, or even thinking about designing a network?
That's the real payoff. And if you want more deep dives like this, exploring essential IT concepts, definitely check out the Acronym Academy YouTube channel.
Yeah, please do. And if this was helpful, we'd really appreciate it if you'd like the video, share it with anyone else studying for Net Plus or just learning networking, and subscribe to Acronym Academy for more content.
And let us know in the comments any questions, any acronyms that still puzzle you, or other IT topics you'd like us to tackle in a future deep dive. We do read the comments.
We absolutely do. Thanks so much for joining us on this acronym adventure.
Yeah, thanks for listening. Keep learning.
Until next time on the Deep Dive, take care.